Good morning and afternoon, evening, whatever time you're watching this. Hello in any case, and welcome to another edition of Algebra 2 Notes with Miss Faust. Today we are looking at how we can find roots of a polynomial and then how we can write a polynomial in standard form given its zeros. So we spent some time finding roots last time, and today before we go any further, I just want to do a little bit of clarification on some vocabulary. So when we have a polynomial, we have standard form. Standard form is the form that looks like this: x cubed minus 2x squared minus 9x plus 18. So standard form is what we've often been starting with in this unit. And then factored form is what we usually try to find first. So factored form of the polynomial, to get from standard form to factored form, you want to watch the last two lessons because those talk a lot about that, how to find possible roots and then try them to get this completely factored. So when you completely factor this, and again, go back to the last two lessons if you need some extra help with that. But when you get this completely factored, you would end up with this: x minus 2 and x squared minus 3. 3 is not a perfect square, so we can't factor this using the difference of squares, which means this one would be completely done in this factored form. This would be its factored form. From factored form then, while we're here actually, these are the two factors. Oops, this pen is dying. Let me just switch pens. I have a different green one right here. These are the two factors of this problem. So when we're looking at this, sorry, I'm just adjusting. There we go. So in factored form, this particular problem has two factors. In addition to factors, we also talk about roots or zeros. And in our case, for everything that we do with polynomials, roots and zeros are exactly the same thing. What those are is those are solutions to the problem p of x equals 0. So what that means is we say 0 equals x minus 2 times x squared minus 3. And then we're looking for the solutions to that. Well, the only way that this side can be 0 is if this piece is 0 or if this piece is 0. So this is where we split it. And we've done this before when we were trying to find x-intercepts. That's exactly the same thing as a root or a 0. So actually x-intercepts is another word to put there. All of those things mean the same thing. So what we do is we say 0 equals x minus 2 or 0 equals x squared minus 3, and we just solve both of those equations. So from this one we'd add 2 and we'd get 2 equals x. And from this one, after we move this down a little bit, we would add 3 to both sides and get 3 equals x squared. And then we take the square root of both sides. When we take the square root, on the right, the square root and the square will cancel, and on the left, we will get a positive or a negative square root of 3. So for this problem, the zeros or the roots are x equals 2, x equals positive square root of 3, and x equals negative square root of 3. And the roots or the zeros they'll always be the same number of those as your highest exponent. So notice here we have 3 roots, and the degree of the original polynomial was also 3. Sometimes you won't have 3 factors because you can't factor this anymore, but you can still find roots from it. And you might get roots these are irrational roots. You might also get imaginary roots where you have eyes with them. So again, this might end up being a quadratic. You might have seen some of those by now. So if it's quadratic, at this stage you do the same thing. You just solve the quadratic formula, and that always gives you 2 roots also. Okay, if you have any questions on that, let me know. Write them in the margins or come and see me. Getting from the standard form to the factored form, we're getting pretty good at. And then most of us, I think, are pretty good at finding the roots and zeros. We just don't always know that's what we're doing. So hopefully that helps you a little bit see what's going on there. So the other thing that we want to look at today in detail is how we can go from the factored I'm sorry, not from the factored form. Hold on. Can't do two things at once. Questions, notes. So the second part of our question was how can you write a polynomial in standard form given its zeros? So if you're given its zeros, so say we're starting with the zeros or the roots of a polynomial, what you can do is you write the factored form first. And then what you're going to want to do is you're going to want to multiply out to get the standard form. Okay, so if we want to get from zeros to standard form, those are going to be our steps. We write the factored form, and again, the factored form comes from the zeros. I'll show you that in just a second. And then we multiply them all out. So say, for example, example 1. Say, for example, we know P of x has zeros, x equals 2, 3, and -1. So what we know then, if those are our three zeros, and I'm just going to grab a different pen here, see how this one works. Having some issues this morning with pens. That one does work. Okay. So the first thing we do is write the factored form. And the relationship between the zeros and the factored form is that each zero, remember the opposite of that goes into the factored form. So we write P of x equals x minus 2, x minus 3, and then minus -1 makes it +1. So that's our factored form. Now we just have to multiply those out. So we're going to take this and we're going to have to do a box a couple times. We multiply 2 at a time. You may not need to do the box. You may do the distributive property. I'm going to do a box just so you can, because that's what most people I think do at this point. So if I do a box with the first two terms, x times x is x squared, x times -2 is -2x, -3x, and +6. So from that part, I get x squared minus 5x plus 6. So that was my first two terms, right? They went into the box, and then they became this. And then I still need to bring this last term down, which is just x plus 1. So now I need to multiply x squared minus 5x plus 6 times x plus 1. So again, do a box if you want, or if you don't like the box, use the distributive property, multiply this by both of these, this by both of these, this by both of these. I find the box easiest, especially when I have 3 terms ever, like I do here. So I'm going to put my x plus 1 over here, and my x squared minus 5x plus 6 up here. X cubed, -5x squared, 6x, x squared, -5x, and -6. And then notice again the diagonals all have the same exponents, so I can put those together. So my final P of x here is x cubed minus 4x squared plus 6x minus 6. And that's my standard form. Because I had 3 factors, I would expect my degree to be 3, so that makes sense. Okay, so this is how we get from factored form back to standard form. So here is the standard form for that equation. I'm going to stop for a second and go find some new pens, and I'll be back with a couple other examples momentarily. Thank you. Okay, so we are writing standard form equations for polynomials with given zeros. So you can see in these two examples, instead of just having integers, we have some imaginary numbers and some square roots. And that's just because, as you saw in the last lesson, polynomials don't always have integer roots or zeros, but we still can write the standard form equations for those. And I'm going to show you some tips. I actually think these sometimes are easier to do than the ones with integers because you end up with a few less things to multiply in the end. So let's start with A. So if we're looking at A, we have our zeros. First thing we need to do is we need to write the factored form. So we look at this 4, we look at the I, and we look at the negative I, and we put each of those into a factor. So we'd write x minus 4, x minus I, and then minus negative I makes it x plus I. So when you look at these, the key to sort of simplifying your life with these is start with the ones with the i's in them. So we're going to start by multiplying x minus I and x plus I. So I'm going to put those in the box first, or if you're using the distributive property FOIL method, I mean, that's totally fine too. So x minus I and x plus I, so I get an x squared, I get an xi, I get a negative xi, and I get a negative I squared. So a couple things to notice here. Xi and negative xi are opposites, so those are just going to cancel out. Because when we have xi and we subtract xi from it, we get nothing. The other thing to notice is that this negative I squared, well, negative I squared equals negative I squared, remember, is negative 1. So really, that negative I squared is a plus 1. So when we write the factored form from this, we're going to write x squared plus 1. Because when we multiply this all out, the other parts cancel, and the negative I squared becomes a plus 1. So the x squared comes from right here, and the plus 1 is from this negative I squared. So we have to simplify these as we do them. Like I said before, notice now we only have 2 parts. So we're going to multiply those 2 parts by our other factor. Because when we're doing these, we always are multiplying all the factors. So we write x minus 4 here. P of x is equal to all that. So now we just have to do x minus 4 times x squared plus 1. So we get x to the third, x, negative 4x squared, and negative 4. And then if you look at those, none of those have anything that can be combined. All of the exponents are different. So P of x is equal to x to the third minus 4x squared plus x minus 4. And we always write the biggest exponent first and then just go down from there. That's what makes it standard form. Okay, so let's look at problem B now. Problem B is very similar, except we have roots instead of i's. So I'm going to try and do problem B on the rest of this page. I can write out the factored form first. So from the 1, I get an x minus 1. From the square root of 2, I get x minus root 2. And then from the negative root 2, I get x plus root 2. And again, the first thing we're going to do is we're going to multiply out the square roots. Okay, so I'll do that on the side this time, just because I'm trying to save some space. X minus root 2, x plus root 2. X times x is x squared. That would be x root 2. I don't know what root 2 is, it doesn't really matter. This negative means that this one will have a negative x root 2. Well, that's convenient, and you'll see why in a second. And then in this box, positive times negative is negative, and the square root of 2 times the square root of 2, anytime you have 2 square roots and you multiply them together, if they're the square root of the same thing, you just get back what you started. So square root of 2 times square root of 2 is 2. So we get x squared. Again, we have a positive and a negative that are going to cancel, and we have a minus 2. So this becomes x squared minus 2. Again, the x squared from here, the minus 2 from here, and then x minus 1. Whoops, I don't need that many parentheses, but that's okay. So we get x minus 1 and x squared minus 2. And now we just need to multiply those two pieces out to get our final standard form. So let's let's see here, x minus 1, x squared minus 2. X times x squared is x to the third. X times negative 2, just focus this a little better. X times negative 2, there it goes. There we go. X times negative 2, still negative 2x. X squared times negative 1 is negative x squared, and negative 1 times negative 2 is positive 2. So our final standard form is x to the third minus x squared minus 2x plus 2. So again, we're just going from finding our zeros, writing them as factors, multiplying out the factors to get to our standard form. Just like in the last lesson where we had our standard form, we looked for factors, we wrote the factored form, and then we wrote the zeros. So we're just going back and forth now, so now we know how to divide polynomials and write them in multiple forms. Any questions, write them down, and come and see me when you can. Thank you very much, and have a great day.